We're gonna now look into a project called Smart Classroom. Classroom project is a project that gives us a taste of what it means for the AI to understand what we say, to understand natural language. And it's called NLP, actually Natural Language Processing. And so let's take a look at what's happening here. We have a classroom that has two gadgets. It has a fan and a lamp. And I can click on the green flag here on Scratch. Yes, Amina?
I already understood how this code works. As for this is a forever loop, so first of all, it might ask enter. It will ask enter your command. So it will ask to give an answer to the question it's giving. Then if the answer is equal to turn on fan or anything related to that, that's where AI comes. Then it should answer. Then it should like start broadcasting the fan to turn on. The moves. What you say? The customized forms.
Okay, thank you, Amina. Actually, I was your teacher in G-code, so I do recognize
I know
you. Okay, so like your friend Amina said. So basically, this program is basically this is like let's call it like Google Assistant, but it's with typing. So I'm gonna type a command, and I need these gadgets to respond to me. So as you say here, if I write turn on the fan, then the fan will start working. And if I say turn on the lamp, then the lamp will start working. This is not AI, by the way, this is regular programming. And it says, if you can see the code, if the answer is what I typed, equals turn on the fan, then we will broadcast turn fan on. It means that we will turn the actual gadget on. And if answer equals turn off the fan, it will turn off the fan, and so on and so forth. So obviously in a real world setting, this is not what's going to happen.
Ma'am, if you like, ma'am, it doesn't necessarily have to be like turn on the fan. You can also like keep the else, like if you don't say, then you can just say, tell that, okay, you have to say turn on the fan, because if they say, for example, on the fan, then like then it won't work now.
Yes, exactly. In a real setting, in a real world setting, thank you very much. We want a program that expects anything. I can say anything. It's not, I don't have to say, I don't have to type turn on the fan with a T that is capital and everything else. The user can write everything. Like when you talk to Siri, you are not bound by what you have to say and how you have to phrase it. You can say whatever you want. And for me, to turn on the fan, I would say fan on. For someone else, they would say turn on the fan. Someone else would say turn on the fan, please. And a lot of someone else will say I'm hot. So a lot of wordings for the same thing that we want the fan to be turned on. But in regular programming, or in this case, what is happening is the computer is asking me to enter my command. It's storing that command into the variable answer. And 1 second, let me finish, and then I will give you the. So it's taken that answer and it's compared it to the phrase turn on the fan character by character. So even if I try, okay, let's type turn off the fan without having a T that is a capital T in the front. Okay, so, oh, I put it up, I'm sorry. Okay, so let's say turn off the lamp. And if I make any error, it will not work. It will not turn it off. I have to say turn off the lamp with a T that is capital for it to work. And this is very not practical in a real world setting. In a real world setting, I want to say anything and I expect my AI to understand what I'm saying. We have to introduce AI here so AI can understand and give meaning to what you're saying rather than just comparing it character by character, which is what happens in regular programming. So who was asking the question? Okay, so I see Alex has his hands up. Is that you who was asking the question?
It wasn't me asking the question before, but I do have a question.
Okay, go ahead. And then anyone who has a question, raise your hands, okay?
Could instead of like we could do the making it so that it doesn't have to be capital T and can be misspelled and stuff. But also, could we theoretically add AI by the computer checking when you would normally turn on or off or on the fan or lamp, and then it like automatically does it at those times?
So Alex, yes, thank you for your question. We can make it adapted to non-capital T, adapted to other sayings, adapted to what I will say, and adapted to 300 different sayings of the same word, but eventually someone will come up and they will say a new saying. It's not something that you can really limit. So for that, we will have to use AI or it will not work. And we will use AI, but we will not use AI for timing. It will not be AI like things that you might turn it on in this time, no. But what we will use AI for is to actually understand what you're saying, to actually understand when you say, please turn on the fan. It will not take all of the words into consideration. It will take the global meaning of what you're saying. Okay, and I will show you how. I see Bucci who's has his hands up. Do you have a question?
No, thank you.
Okay.
Miss, when do we work? Like, when do we come on the? What days do we come on Zoom and do the thing? Like, we come and join the Zoom. What days do we join the Zoom?
I'm sorry, when did we join the Zoom?
Yeah, what days do we join the Zoom? Like,
We joined the Zoom at 6, no? Okay, go
no,
ahead
like what
again.
days?
I'm sorry.
Like what?
Saif, do you have a question?
Miss me?
It is something about the facial recognition, and it does involve CAD files. So
Okay,
if
then
you
we will ask it after the session is done, okay?
yes, that's fine.
Then, okay, let's go ahead back to the project then. So like I said, we can theoretically just add as many phrases as humanly possible that we can say. But like I said, people make grammar mistakes. People always have something, some new slang and everything like that. So we need the computer to be able to understand and not compare. Comparison, it's not even feasible. Like you will not have the time to write down every possible solution. And we are only talking about 2 gadgets. So imagine if you have a smart house and you have a lot of gadgets to control. So for this solution, we will use artificial intelligence, and I will show you how. So let's go into this platform. It's called machinelearningforkids.co.uk, and it's a platform that enables kids to create machine learning models or AI programs, and you will see how. So I'm going to click on try it now without registering. And guys, in the worksheet I'm going to give you, you will have all of the links and all of the steps. So don't bother with that now. I'm going to add a new project, and I'm going to call the project Smart Classroom. And this Smart Classroom project, whenever you create a new project, you're going to have to set which type of data are we dealing with. So for the Smart Classroom, in our case, I'm typing the commands. So it's going to be taken text. If I'm dealing with something like Siri, where I have to give verbal commands, that we're going to go with sounds. If we're going to create a project that, for example, distinguishes dogs from cats, then we're going to give it images. So that's images. Numbers is for something like, for example, a project that the input is, for example, blood pressure. So you always think about what is the input here? What am I giving to the model so the model can analyze it. And in our case, we're given a text. I'm typing the command. And we're going to do it in the English language. And click on create. Okay, so you see now that I have a new project added to my machine learning projects, and I can click on it, and you will see that we have 4 different things. We have train, we have learn, we have test, and we have make. The make part, let's leave it apart for now. That's the part where we're going to make our application interactive with Scratch 3. But let's look into train, learn, and test, because these parts are crucial in every machine learning project, no matter how big it is. So even if you're talking like corporate level, very big AI projects, they will always have the train, learn, and test phases. So for the train is where you collect examples of what you want your computer to recognize. So the computer takes in examples, learns through those examples, and is now able to recognize future commands. So it takes new examples in the train, it learns these examples in the learning phase, and then in the testing phase, you can give it a new command and expect it to be able to recognize it correctly or to categorize it correctly. So let's go into train. When we click on train, you can see that we have a button here that says add new label. And the labels are what the categories that we need for our computer to categorize. So for example, if I'm making a project about an AI that recognizes dogs from cats, then I'm gonna have 2 labels. One label that is dogs, and I'm gonna give it a lot of examples of dogs, and one label that is cats. So what is my computer recognizing or categorizing in this case? So those are my labels. Can anyone have any guess as to what these are? Yes, Diana?
So I'm guessing that you'd have categories like fan on, fan off, lamp on, lamp off.
That's very good. So I'm gonna have categories like fan on, fan off, lamp on, lamp off. If I have another gadget, then just the same thing. Anything that I need to do, basically any command that I wanted to interpret, I'm gonna have as a label. So yes.
Ma'am, you were saying something like this one. Like if you say just the fan to turn off, it'll turn off, right? But then again, like also now we use the remote and all. So like how can we like like just increase that, because like now only like it's only happening in like the northern region where, and then also like how can we like increase that to like all the world? That
Do you mean the use of AI?
yeah.
Well, that will be very, very highly dependent on the obviously on the financial resources, on how the governance is doing everything, and how I don't know. It doesn't depend on us anyways. It's not something that we have a lot of hands in. I think it has mostly to do with financial resources. So yeah, for now, yeah. It's not very common to have smart houses even now. But you do have your Google assistants, I guess. That's very, very like reachable. You can find it anywhere. Okay, so let's go back to our lesson. So like your friend says, we're gonna have labels. If I want my program to turn off my lamp, then I want it to, when I give it a command, to categorize it as a lamp off command. So those are our categories. To figure out what are labels, what you need to put as labels, it's just a bit of a thought process. Like just think of what am I recognizing and how, or in what categories do I want my computer to be able to categorize it? And these questions are very dependent on each project, but like with a little bit of thinking, you can figure it out. And in future, if you do future projects with us, you will get the intuition for it. So for our first label, we will have lamp on. And whenever the computer recognizes something as this, I want it to turn on the lamp off. The same, and fan on, fan off. Guys, I'm gonna ask you to stop using the chat, please. Thank you, and focus on what I'm doing. Okay, so now we have our 4 fans. Obviously, if I had another gadget, then I'm gonna add two other labels. And for now, we have only 2 gadgets, so we have 4 labels. For lamp on, I will add now examples of what I could say to the computer and for it to understand that it is lamp on. I could say lamp on, as simple as that. We can say, please, a lot of examples. I will just write some down and then you can write yours down also when you're working. Please turn on the lamp. Lamp on, please. Also, I can say it's too dark. Also, I can say I can't see anything. I think I can't see anything should be determined, should turn the lamp on. Just give it various examples, like different examples that will give it a pretty big range of what people could say, not just lamp on, lamp on, lamp on, please, lamp on with a capital L. You know what I mean? Like give it more.
Teacher,
range.
can I say an example?
Yes, go ahead.
I can't see very well.
I can't see very well. Okay, that's very good. I can see very well.
Can I say
We also try with
Can I say
pencils.
one?
Guys, keep your examples so you can use them in your projects, or you will be done with the examples in my project. It's too dark. Lamp. Turn on the lamp. Did we say that? No. Turn lamp
Can I
off.
say one?
Yes, go ahead.
We can say time to sleep. So he thinks it's night, so he does not need the lamp anymore on.
It's morning. What can I say?
It's time. It's dark now. It's dark in here.
Ma'am, you can say it's morning. So
Okay.
I mean it's
yes.
night, it's night, it's night. You can
Okay.
Turn off the light, please.
It's
for
nighttime.
no ma'am, for lamp off, it's this one morning. That's what I'm doing.
Turn off the lamp.
Ma'am, what if one person wants to switch on the lamp and the fan?
I'm sorry?
Ma'am, what if one person wants to switch on the lamp and the fan?
Then you have to say the same message.
Okay, so if you want to switch on the fan and the lamp, you're gonna have to create a label called lamp off, lamp on, and fan on, and then write a whole, write something that says that you have to open both. But you cannot put the lamp on and the lamp on and the fan on and just call it a day. You have to make phrases that have the both components. Or you can, in the code afterwards in Scratch, you can test on 2 variables and say if lamp on and fan on, then broadcast lamp on and fan on. Like you have to tell the user to enter 2 commands. You have, 1 second, you have to tell the user to give you as input 2 different commands. And in the first one, you can test it if it's lamp on, and it means like it will not be executed unless both are correct. And the second command is fan on, then broadcast fan on and broadcast lamp on. Or you can have a label here that says lamp on and fan on in the same label. And you can say, please turn on the lamp and the fan, and give those types of examples, okay?
Okay, ma'am. So the broadcast will have a AND operator.
Yes.
Ma'am, can't you just do
Okay.
like lamp on, turn the lamp and fan on? So like only then lamp will on and then you do the same for fan on.
I'm sorry?
No, like if you want to turn on both the lamp and fan, the lamp you just say like turn the lamp and fan on. So then it'll only then the lamp will on. Then do the same thing for the fan on.
I'm not sure I understand what you're saying, honestly.
No, like you keep the same sentence in both lamp on and fan on, like on the lamp and fan. Then only if you say
Oh, okay. I see what you mean. There are a lot of things that you can, you see this model, it will only have one input. So if you have the same thing in lamp on and the same thing is in fan on, it will only confuse the model. But at the end of the day, it will give you one output. It will not give you, oh, this is lamp on and fan on. Do you know what I mean? There's only one output from the model. It will only pick one label. And if you put the same example in more than one label, it will only confuse it. It will only make it less accurate for other examples. It will be confused. Why does this exist here and here? Okay, guys, let's finish the examples. Otherwise, we will never be able to finish this. Lamp off. Okay, it's already there. Lamp off, please.
Turn off the lamp.
Please turn off the light.
I'm trying to.
Night is
Light
ma'am, it's too
daytime.
Guys, can you please mute your mics?
Teacher.
Guys, please mute your mics. Thank you. Now, who has a question?
Can I say that
Teacher, can I
in my room I turn on the lamp?
Okay, leave your examples for your projects, okay? We don't have time to take more examples. Who else has a question unrelated to examples?
Teacher, now we're talking about.
Guys, can we please keep the questions till the end of the session? If you have any questions related to the topic now, can you just raise your hands? I think there is one question from Ruba. Ruba, do you have a question?
Yes, I have a question.
Go ahead.
Can we put anything in the fan on and the topic now? Can we do anything we want, or just? Teacher, can I say something?
Can we do anything we want in the fan on, fan off?
Yes.
It must make sense. It must make sense. You can just try whatever you want.
Miss, can I say something?
Teacher, can I say something?
Guys, if you have a question, we will answer it at the end of the example. Please leave so we'll have more examples because we don't have time anymore.
Did we answer the questions for Ruba? Her question?
I'm sorry?
Ruba, did we answer your question? I think let's continue, Shayma.
Let's continue. Okay. So we need to come up with two more examples here. Let's see. Fan on the fan on, please turn the fan on, turn the fan on.
Miss, can I say something?
Teacher, can I say something?
Okay, go ahead.
Yes.
Go.
We can say that we can like say
It's too hot to. Can you turn on the fan?
I am too hot. Turn
No,
on the fan.
it's too hot.
It's too hot. It's okay. And we need 2 examples for fan off. Give me 2 examples for fan off.
Can I say
It's
one?
too cold.
Teacher, can I say one
It's
about
really
fan off?
cold.
Can I say one?
Cold. Yes, go ahead.
I'm freezing. Teacher, it's so cold in here. Turn off the fan.
Yes.
Ma'am, you can also say I feel it feels like
I'm
Antarctica.
feeling cold.
Okay, I think this is enough. And
It
then
feels
we
like
will
Antarctica.
let's try with this one. So I click back to project. Now we have our training data, which is labeled data full of examples, and we should now go to the learning phase. So for the learning phase, our model, we can see here, there's a button that says train new machine learning model. When I click on it, it will take a couple of seconds. And what it's doing in these couple of seconds is that it's going through the examples that I've given it and trying to make sense of them. So through a lot of features, like how it's punctuated, how it's structured, the keywords that I'm using, now it understands what it means to say to fan on. And please understand that in bigger scale projects, we do not give it 7 examples, obviously. It will be thousands and thousands of examples of what the person can say. But after the training, the model now is not dependent on the every single word of the phrase. Now it can understand more meaning through, like I said, features like how it's structured, what are the keywords that are being used, what punctuation I'm using, or all of these features. It's all of that analysis is done in the training. And now, after it's done training, it gives me the option to enter test text here, so I can test it. And to test it, we will have to enter something that we did not give it in the training to see if it's actually doing good. Because if I give it something in the training, it will just recognize it because it knows I already put it in the actual. So give me an example that we did not give in the training, guys.
I'm
Yes,
really cold.
I'm really cold. Okay, we did not say I'm really cold. I'm pretty sure. I'm really cold.
I am freezing.
Okay, I'm freezing. We already gave. So you can see that it recognized.
Teacher, can I say something about code?
We will. Okay, 1 second. Let's finish this, and you can say whatever you want. So it recognized it as fan off. As a fan off command, which is what I wanted to do, which is accurate with a 95% confidence. This confidence score tells me how accurate my program is. If it's very high for something that is correct, then it's accurate. Like if I say here, I want pizza, I will expect a low confidence score, or my model is not that accurate, and I will tell you how to fix it. So as you can see here, what did it say? It recognized it as lamp on, which is correct. It will always recognize it as something, but with 11% confidence. And when the confidence is very low, it means that the model is guessing. It doesn't know what it's doing. And for something that doesn't make sense, that's a good sign, because it means that my model is not just recognizing randomly things. So I need high confidence for correct things and low confidence for things that do not make sense. If I don't find this in my model, then I'm gonna have to go back in the training and give it more data, because the accuracy of any AI model in the world is highly dependent on the data we feed to it. Whether this data is big enough, whether it's like it has a lot of variety, or is just the same words that I'm rephrasing, and all of this is taken into account. Now we're gonna very quickly go into Scratch 3 and try to integrate this into the program that we already saw, but this time we're gonna do it with machine learning. So we're gonna go to project templates, smart classrooms, easy. And you recognize this, right? We saw it at the beginning of the session. We have if answer equals turn on the fan, then broadcast turn on the fan, if answer equals, and so on and so forth. Now I'm gonna have to change this. I don't want it to compare the answer to the phrase. I wanted to compare what my model is outputting. So as you can see here, we have a smart classroom, little machine learning blocks. This is not, you cannot find this in Scratch normally, but if you open Scratch through machine learning for kids, you can find it because it's machine learning related. And I have this block here. What does it say? Recognize text and return label. So it will recognize text of this variable here, and it will return the label. And what this means is it will take the text that I put here and run it through the model I created in machine learning for kids and return the label so that the model returns. So basically it's doing this part. Basically it's doing this part just interactively. Okay, it's doing this part. It's putting it here and returning what the model outputs. And if I put answer here, then the model will take the answer that I typed, whatever command I typed, and run it through the model and return the label. And if this label is equals to the label of lamp on that I created, or not lamp on, I'm sorry, fan on here because we have broadcast fan on, then I'm gonna broadcast fan on. And this way, I'm not comparing character by character, strings character by character, but I'm comparing what my model is outputting to the this label to be able to know what my model is outputting. So if my model outputs fan on, then I will broadcast fan on. If my model outputs fan off, I just put it here and we do the same. This is fan off, so I take the label fan off, and I will do the same for both of these things. Does anyone have any questions? Does it make sense to you guys what I'm doing or no? Yes, yes, Ziana?
No, I get what you're doing. Sorry, my hand was up from before.
Okay. Malik? Also no. Okay, no problem. Saif? Saif, do you have a question?
No, teacher, I don't have any questions.
I do.
Thanks.
Okay, Jad, do you have a question?
I don't know anything because I joined, but then I left, so I don't know what you're doing.
Don't worry about it. Everything is recorded.
Everything is recorded, and I'm going to send you now in the chat the worksheet that you will have to follow to recreate everything that I did, okay? So don't worry. Yes, Rauda?
Yeah, I was just wondering, I understand what you wrote, but are we going to get the links to these programs so that we can
Yes, yes,
do them?
100%.
Okay.
I'm going to send the PDF now in the chat, and you will find the links, you will find the steps and everything in the PDF, okay?
Okay.
Okay, let's test it, guys, very quickly, just here, and then we can wrap this up, I guess. Okay, if I click on the green flag, now it's asking me to enter a command, which it did also before. So I can enter a command, but this time I'm not bound to enter, turn on the fan, turn off the fan. I can say whatever I want, and I can try with the example that our friend said, I'm freezing. No, not I'm freezing because it's already, I'm hot. I'm very hot. Okay, I'm very hot. And let's see what happens. Yes, it started it. And if I'm saying I'm very, very cold, it stops it. Even though these words were never explicitly mentioned in the code. And now I have more freedom to say whatever I want. Of course, the data that I provided for the training should be representative. I can't just say whatever I want. or if I want to say whatever I want, I should just add more data. If the model is accurate enough with enough data, then you literally can say whatever you want. But for now, what we have achieved is we achieved a model that can understand what I'm saying without it actually having to compare by regular programming, but by understanding the meaning behind what I'm saying through the use of features like keywords, like the structure of the phrase and the length of the phrase, and a lot of other things.